the probability and interpret the results. Okay. Population mean annual salary for environmental compliance specialists is about. So we have X and the mean, they say 61,500. Random sample N equals 45. I have to take notes. What is the probability that the mean salary is less than? Okay, so sigma, they are giving us 6,500. And we want for part A, the probability that the mean salary of the sample is less than 5,800. Okay, 58,000, sorry. Okay, I'm going to stop sharing for a second. So as we know, X is given to us as being normal. Let me double check. I'm sharing again for a second. Okay, they're not telling us that X, the population mean annual salary for environmental compliance, especially is about such and such. Okay. What is the probability that the mean salary of the sample is less than? Okay. But we know that since the sample size is over 30, we know that X bar is normal. Here we do not know that it's normal or not. They're not telling us. With 61,500 and sigma 6,500 divided by the square root of 45. So now for the probability for X bar, the sample mean, to be less than 58,000, then I have to use, if I'm using the TI-84, then I have normal CDF from negative infinity to 58,000 with a mean of 60.
I cannot see when you write.
Of course you can't. Okay, I'm sorry. Let me start from the beginning. So we don't know that X is normal or not. They're not really telling us. But the sample size, thank you so much, thank you. But the sample size is over 30. Okay, so we can assume by the central limit theorem that X bar is normal with a mean and a standard deviation smaller by the square root of 45 smaller. So in order to determine that the sample mean is less than 58,000, we have to use the normal CDF from negative infinity to 58,000 with a mean given to us and the standard deviation as 65,000 divided by the square root of 45. So I'm going to share my screen now. So here it is. So second and distributions. I go to normal CDF. I press enter. Nice, from negative infinity, that's okay, to 58,000. And with a mean of 61,500. And the standard deviation, the 6,500 divided by the square root. The calculator will do it for us, unless we need to put a standard deviation in there, and we can determine that if we need to. And or the standard error of the mean. Okay, good. So careful, if you put a probability of 1, that would be a terrible mistake, so be very careful. Read all the way. So this is 0.3015,189. So this is our first answer. Probabilities, as we know, this is the probability, has to be between 0 and 1. If you write 1, then you know something is wrong, unless you read the rest and you write times 10 to negative 4. But, okay, let's see. Where is it? I lost it. No, I didn't. Round to 4 decimal places. Okay, so I have 0.3 zeros and a 1. Part B. Interpret the results. Choose the correct answer below. Okay. Only point. My mouse is not working. What is going on? Okay, now it's working. Okay. So only a 0.02% of the samples of 45 specialists will have a mean salary less than, and this is an extremely unusual event. It is extremely unusual. So the sample size is 45. Yes, it is. Okay, so only 0.02% of the samples will have a mean less than 58,000. Only 2% will have a mean salary than this. About, so this is 0.02. Oh, okay, I see. So they want to catch us somehow. So 0.02. They're not asking us to round this up, but I'm looking at the number now here that I wrote on paper. So it's approximately 0.02. This. So between these two, only this. So about. So now it's actually an exercise in English language. So only this, about. So this is an unusual event. So this is an extremely unusual event. I agree with that. But it's not 2%. Because if you move the decimal point, multiplying this number by 100, you will get roughly 0.02%. And if they wanted here 4 decimal places, then I should have, it took it correctly, but it's not. So I put in 4 digits, but I should have put in 0.0002 because it's 1, 5. So that's why this is correct. This is incorrect. It accepted it, but I should have put 0.0002. Okay. Only specialists have a mean salary less than this. This is an extremely, yes. 2% is incorrect. It's just multiply this by 100. But let me stop sharing for 1 second just to say that I look here at this number. I should have correctly increased 1 to 2. So this is 0.0002. And when you multiply by 100 to change it into percent, that's how you get 0.02%. And this is less than 5%, which is very, very unusual. Okay, but again, it took it because they also have some tolerance, plus or minus, but you shouldn't have considered it correctly. So that's why I got a little bit confused here and said, oh, what is going on? But the question was, the problem was it accepted this. It should have not. The correct answer is 0.0002, and that's why we get this. Very good question. Anything else? Anyone? Was this the question, Emma?
Yes, thank you.
Thank you. Is this clear? Yes.
I had a question.
I'm ready.
I think it was 8.1, question 14.
8.1, question 14.
Mainly part B.
Okay. I can't skip it because I have to go to A. I'm having difficulties with my mouse. I'm not sure why. I have to reach my laptop somehow. Yes, something is going on with my device, and I'm not sure what it is. Okay, now it's working. Okay, we'll see. I have to probably get a new mouse. I did replace the battery before you ask. Okay, and one more time, you said number
14.
Thank you very much. Let's look at 14. The overhead reach distances of adult females are normally distributed with a mean. Okay, I have to take notes. I'm taking notes. So it says normally distributed. Now this is clear. Normally distributed, the mean at 195 and standard deviation of 8. Okay. Find whether the individual distance is greater than. Okay. So I'll stop sharing. Greater than 204.30. So this is probably 204.3. So I have to use normal CDF, normal CDF, with starting at 204.3, comma, infinity, comma, 195 and 8, because this is for an individual. So I'll put it in the calculator. I'll share my screen. Okay, now the mouse is working. I'm not sure. Okay, so I want normal CDF, and from 204.3 to infinity, as you know, EE99, and the mean, it was 195, and standard deviation was 8, and that's it. And I get 0.122516. Okay, next question. Round to 4. Let me be careful now. 1225. That is correct. 0.1225. Okay. We check the answer. Okay. Good. Find the probability that the mean for 20 randomly selected distances is greater than 193.7. So let me take notes and I'll stop sharing. So now we want the probability that the mean is greater than 193.7. So let me stop sharing now. Okay. So this is normal CDF from 193.70 to infinity, comma, the mean, which is the same, 195 as we know, and the standard deviation is 8 divided by the square root of the sample size. And the sample size was, yes, I know I lost you for a second. I'm so sorry. The sample size was 20. Because they are normally distributed. Okay, so the sample size is 20. I can use this because I am told that X is normal. Although this is smaller than 30, it's okay because I am told that X is normal. Okay, so now I'm going to enter, where are you guys? Okay, so I have normal CDF. I'm just going to simply copy the whole entry. I only need to make 2 changes. I have 193.7, 193.7. The mean is the same, infinity is the same, but 8 divided by the square root of 20, and close. So the probability is 0.766301. Okay, so where is it? Round to 4 decimal places. So 7663. Okay, part, why can the normal distribution be used in part B even though the sample size does not exceed 30? Because I'm told right here, they are now normally distributed. There is no question. If they are normally distributed, no matter what the sample size, X bar will always be normal. The normal distribution can be used because the original population has a normal distribution. Okay, the normal distribution can be used because the mean is large. The normal distribution can be used because the probability is less. Nice try. The normal distribution can be used because the finite population, whatever they come up with. Nice. Good. Anything else? Other questions for me? Okay, so now we'll continue with chapter 9. So let's start chapter 9. Chapter 9 is about point estimators. what is a point estimator? Just remember one thing. In the previous chapter, we looked at two fictitious variables. These variables gave us information about the population mean. That's why the notation is so important. That's why please remember. And the population proportion. Okay. Those are called point estimators. This is the point estimator of the population mean, and this is the point estimator of the population proportion. So in these two sections, 9.1 and 9.2, we're going to talk about this and about this, the so-called point estimators. Now, before we analyze again what these estimators mean, etc., I just want to make sure that we understand one thing. If we are going to say, or when we are going to say that X bar is, and that's what the point estimator is. So let me start with that. So X bar is the point estimator of mu. But we also want to look at an interval that estimates or gives a range where we, and this is very important, are whatever percent we decide confident it contains mu. So let me read this one more time and discuss this. So now we know that this is the point estimator of mu. We established that in chapter 8. But now we also want an interval that gives us a range where we will say we are 90% confident. This is not the probability. So this is the key word. You're going to see that in a minute when we get to examples. So we are going to be asked to find the point estimator, and then we're going to be asked to find the interval called confidence interval, where we are 90%, 95%, 99%, 80%, whatever you want, percent confident that it contains the true population mean. This is the true population mean. The same thing with the proportion. So P hat is the point estimator of the population proportion P. I'm going to write it here. Same thing for P. So X bar is the point estimator for mu. P hat is the point estimator for P, true population proportion. And we will be able to find confidence intervals. 90%, 95%, whatever we decide. Confidence interval. So we are 90%, 95% confident that it contains the true population mean or the true population proportion. Now, I want to discuss one thing about when we say, I'm going to give let me just stop.